The final example I'm going to look at is more of an applying situation. So it's bringing a couple of the areas together that we've done. So we've got a cyclist with a mass of 110 kilograms accelerating along an 80-meter stretch. We've got an initial speed and we have a net force. So we're not talking about resistances and force from the cyclist, it's just an overall net force in this question. So as with any good mechanics question, the way to start is with a diagram. So we've got our 80-meter stretch here. And we have our cyclist who is 110, has a weight of 110 G's at either end, and we have an initial velocity of 2 meters per second and a final velocity that we do not yet know. Okay, so there's a couple of steps to this. First of all, we need to look for our work done. Now, we know that we're applying a force of 45 newtons. And from the work we did in the last section, what we can say from here is that work done is equal to force times distance, which is equal to 45 times 80, which gives us 3,600, and it's joules again here. Now, relating to what I talked about earlier in this section is the fact that work done is also equal to the change in kinetic energy. So in this case, that's going to give us 3,600 is equal to half mv squared minus half mu squared. Now, just to save a bit of writing, I'm going to factorize that out a little bit. So we get half times 110 v squared minus 2 squared. So now it's just a case of rearranging that and solving to get our unknown v. So we're going to go 3,600 divided by 55, which is our half, and our 110 is equal to v squared minus 4, which gives me v squared is equal to 69.45 by doing my divide and then adding my 4 on. So finally, to work out my velocity, I just square root that, which gives me 8.33 meters per second. And that's the 3 significant figures. And that's it done. That's the velocity, the final velocity calculated. Let's straighten that up a bit. That's the final velocity calculated given those initial conditions. And that is how work, kinetic energy, gravitational potential energy and work done all linked together. So what I suggest you do now before the lesson is have a go at questions 1, 2 and 3, which are on page 71 of the textbook. And if you want any further help with anything, there are more examples and a few more notes going from page 68 to page 70 of the textbook.